Welcome to the AI Cafe today with our great speaker Andel Gugu. Hi, and it's great to see you already here with us in the cafe. It's the most important. That's why we are all today come to listen to you. And my name is Carmen McWilliams. I'm the organizer and moderator of this AI Cafe. It's part of a European research project called AI for Media. Today, the talk of Andel will be about named entity recognition using deep learning approaches for extracting entities. And as always, this will be an interactive cafe. So first, Andel will present, and then afterwards there will be a question-answer session. And please send us your questions per message. There is, like, on your right side, there's a toolbox, and you can send chat and questions and just send it to us, and I will read it to Andel, and hopefully he can answer. And now I will introduce the speaker. Andel Gugu works as a research engineer. He has a master's degree in computer science from the University of Bonn, where the main track of his studies was intelligent systems. During his studies, he specialized in courses covering machine learning, artificial intelligence, and neural networks. His interest in these subjects aligned with that of Fraunhofer IAIS, where he started working as a student assistant in November 2019. During his work, he became familiar with different media analysis services and the technologies behind them. He wrote his thesis on DL-based entity recognition models under the supervision of media analysis platform team's leader. Last year, he switched from being a student assistant to working as a full-time employee. He's now part of the team that develops and maintains the mining platform, but he also works on improving the quality of some of the existing media services provided by this platform. This is again great that you're here, Andel. Thank you. You will now soon become the moderator. For those who don't know IAIS, this is an institute from Fraunhofer in Germany. Didn't say it before. And they are located in St. Augustin by Bonn. We Cologne people say by Cologne, but it's actually by Bonn. And yes, again, great that you're all coming. This is our first cafe for this season. Maybe some of you forgot what the cafe is about. The cafe is an online forum to gain insights into the European AI scene. Participants get the chance to share knowledge and experiences and meet stakeholders from various areas of AI research and application. So in short, if you feel like networking afterwards, you may send me, or hopefully also you, Andel, email. And this is the idea of the cafe, that we meet each other, even though we are not in the same location, space in the moment, we are virtual, but this should not stop us from communicating and networking. So now I will make our speaker the moderator. This will always take a moment. I have to give you the rights. So you should be now slowly getting the rights. And then I hand over. Yes, I see it already. Presentation is there. Great. Maybe full presentation modus would be great. Yes, super.
So thank you for the brief introduction, Carmen, and hello to everyone, and thank you for showing interest in the topic that I'm about to present now. So we are going to talk about named entity recognition, which is a text-based task, and more specifically, the deep learning approaches for extracting entities from a text source. So what we will do is firstly give an introduction to the task of NER, or named entity recognition. We will see how the approaches have evolved throughout the years, and then we will dwell into the world of neural networks. We will see what's the typical architecture that tackles the task of NER in deep learning, and then I use this approach to answer some research questions. These research questions are a comparative evaluation of word embeddings for NER. So how does the choice impact the performance? Then we will see how we can update deep learning NER models such that they can pick up on the new entities while the language evolves. And last but not least, we will talk about how we can train multilingual NER models. So instead of training one model per language, how do we make sure that a singular model can extract entities from multiple language sources? And then what I call conclusions are the main points that you might want to take away from this presentation. So first, let's introduce the task of NER. Maybe most of you already know. It can be described as finding each mention of a named entity in a text and labeling its type. A named entity can be a word, but it can also be a group of words that identifies an item from a set of items with similar properties. Usually in NER, such predefined entities are locations, persons, and organizations. As we can see in the picture in the left, on the right, I'm sorry, we have a sentence. It's a German sentence, and we are feeding this sentence to a named entity recognition system, which in turn outputs the desired named entities, or the extracted named entities. Each of them is made up of three elements. The first and the second one are the start and the end indices, which tells us where an entity starts and where it ends. And the third element is the label. So for example, Albert Einstein is composed of two words and it's a person, Ulm is a location, Württemberg is a location, and so on. Even though it might seem like NER is conceptually simple, it is still a challenging task to solve. Why? Because of two main reasons. There is an ambiguity in the defining what an entity is and what is not, as well as the number of words that this entity might span over. And there is also another ambiguity in type. There are words, for example, Washington, which depending on the context it's being used in, can be either a person, but it can also be a location. So context is really important in solving the task of NER. Named entity recognition is particularly useful for building a high-level overview in large corpora scenarios, because references to the same entity found in many documents can be used to connect these documents or to establish relationships between these documents and group them together. This allows for better querying, for example. And some use cases of NER also include the search or recommendation engines. NER can be used to improve the speed or the relevance of search results or recommendations, but it can also be used in human resources when we want to probably extract information or summarize applicant CVs, as well as in healthcare to extract important information from lab reports, prescription, etc. Last but not least, NER is also a precursor step to many other natural language applications. This can be question answering, text summarization, etc. So all of these scenarios prove that NER is a key component, and it is one of the first stages in deep language understanding. Therefore, it is very important that we have high-performing NER models. Because of the importance it has, NER has received attention since the 90s from the NLP community, and several approaches have been developed to solve this task. The earliest one is the rule-based approach, where a group of linguists develop some set of rules that you can use to extract entities. Later on, there were some other approaches like the domain-specific gazetteers or syntactic lexical patterns. Just for information, gazetteers are just some long lists of names or of locations. This approach worked well when the lexicon was exhaustive, so we know exactly what we are looking for. However, it is language dependent, and it showed a poor performance on other domains, so it fails to recognize unseen instances. Later on came the machine learning approaches. Here we can mention hidden Markov models, support vector machines, and conditional random fields, which are quite popular even nowadays for the task of NER. They showed better performance than the rule-based approaches. However, they heavily rely on engineered features, which take time, but also require previous knowledge to build. So what about neural networks? Neural networks have become quite popular nowadays. So what if we use them for the task of NER? Can we? Of course we can. They have even obtained state-of-the-art performance in multiple languages. So if you can see at the picture, I'm illustrating the structure of a typical neural network. They are built like the human brain with neural nodes connected like a web. And what makes them interesting is that they can learn complex or hidden features from the data, underlying features from the data, instead of relying on engineered features which are expensive to build. And the task of NER benefits from this as well. So now we will concentrate on the deep learning NER. So the first thing to know is that the most popular architecture for NER nowadays is the bidirectional LSTM with a CRF layer on top of it. This architecture uses no language-specific features. So it uses only a small amount of labeled training data. And it has been introduced by Lampel and others in 2016, and it has obtained state-of-the-art performance in NER, if I remember correctly, in 4 languages in that paper. I'm also giving an illustration of this specific architecture. So I will explain it now. Going from bottom to top, we first have the layer word distributed representations for input. I call them simply word embeddings because that's what they are. So each word is assigned a word embedding, which is a vector representation that captures the semantic or morphological information of words in text. These embeddings are later fed to the bi-LSTM layer, which is also like a context encoder. Why? This layer is composed of 2 chains of LSTMs, which process these word embeddings, or process the whole sentences, in fact. And one of those chains processes the sentence from left to right, and the other one from right to left, so that they can include information coming from both sides. These 2 representations from each side are later concatenated into a single one, and they are fed to the last final layer, the tag decoder, which is just a CRF layer. It will predict tags for each token based on these new embeddings generated from the middle layer. This has been or has shown to be quite a nice and effective deep learning architecture for NER. So I thought it makes sense to use it as a starting point for investigating 3 aspects that I came up with during my thesis. And the first one is investigating the impact of different word embeddings in the performance of the model for NER. So how does the choice impact this performance? Here I worked with German text, since that was relevant to the company that I was working in. Then we will see how can we update pre-trained deep learning NER models so that they can pick up on more recent entities. So it's not important to have a good performance now, but also for the future. So how can we ensure that? And the last aspect is how to come up with a single deep learning NER model that can extract entities in multiple languages. This is also shortly called multilingual NER. So for my experiments, of course, I needed some framework, I needed some data, and I needed some metrics to be able to compare the models that I was training. For the framework, I used the Flare library, which is an excellent NLP framework written in Python. It is based on PyTorch, which is one of the most popular frameworks for deep learning nowadays. Flare is actively maintained. There are multiple releases throughout the year. It is well documented. It was really easy for me to use. And it also offers pre-trained models which are ready to use so that other researchers can replicate the results and possibly further improve them. For the data sets, I used several sources. So for the German data sets, I'm using the two biggest available data sets, which are from the CoNLL-2003 shared task, as well as GermEval2014. For other languages, specifically for English and Dutch, I'm using the CoNL-2002 and 2003. And for the metrics, I'm using the traditional metrics for the sequence labeling tasks. These are precision and recall. And lastly, the F1 score. So precision takes into account only the entities that have been correctly labeled. Recall takes into account also the entities that have not been correctly labeled. And F1 score is simply a combination of these two metrics. It is a score from 0 to 100, and the closer it is to 100, the better the performance of the model is, basically. This is how you should interpret it. So let's go to the first aspect. So what I did, I wanted to investigate several word embeddings for NER. In the picture, you can see this is just a visualization of word embeddings. Each dot represents a word. And the idea behind this is that words that have similar meanings, they tend to be close to each other, so that you can see some clusters. They form clusters here. You can see the body part cluster, the food or the travel, feeling, city, etc. Nowadays, there are multiple types of word embeddings that you can use for your tasks. However, they are all grouped into two main categories, the static and the contextual embeddings. The static or the traditional embeddings technique, they produce a single global embedding for each word. So that means whatever the context the word is being used in, the same word will have the same embedding. And so this ignores the word's contextual information. And the ones that I picked for my investigation were the character level embeddings and fast text embeddings. The character level embeddings I chose because of the language that I was working with. I'm working with German. And it is a special language in the sense that you can combine, you can throw multiple words and create a singular long word, which is not in the dictionary. So character level embeddings are said to be dealing better with these out of vocabulary words. And fast text embeddings, on the other side, they model the morphological information of the words. On the other side, we have the contextualized embeddings, which are dynamically generated. And the embedding generated for a word depends on the other words in the sentence, which means that a word can have multiple embeddings depending on the context it's being used in. So I investigated FLAIR embeddings from the same framework that I'm using. I investigated multilingual BERT embeddings as well as German BERT and German Electra. In their paper, they are called they are considered as among the best models for the German language. So I had to try that out. So what I did is I used a bidirectional LSTM with a CRF layer on top of it. I used this model using different embeddings and training them on both data sets, on GermEval and also on CoNLL-2003. And these are the scores. So here the x-axis represents the F1 scores and the y-axis represents the type of embeddings that I used. In dark blue, you have the results for GermEval dataset, and in green, you have the results for CoNL-2003. So the most striking observation here is the best performance is always achieved when we are training on the GermEval dataset. This is because of the better quality annotations that the GermEval dataset has. In their paper, they state that the process of annotation went through several phases. There were a lot of people included in this, and they made sure that there is some consistency in these annotations. And this also shows that the better quality data you have, the better your trained model will be in the end. Another observation that you can make is when we go from bottom to top, the performance is increasing. That's because we are switching from using static embeddings to using contextualized ones. So that gives us the impression, or that confirms that better performance is achieved when the embeddings that you are using incorporate some context in it. And the best performance in both datasets was observed or was obtained using the German BERT and German Electra embeddings, which is also expectable in some way because we previously mentioned that they were amongst the best German language models, at least at the time when I was writing my thesis. Of course, this is only one score. It doesn't tell us much. It just tells us that it is more accurate, but it doesn't tell us about the strengths or the weaknesses of each of these models. Why do these models perform the way that they do? So I did some fine-grained analysis here. So what do I mean with that is I partition these entities into groups based on some criteria that I choose. For example, I chose entity length. So all the entities having entity length 1, I put in one group. The entities with length 2, I put on another group, and so on. And I calculated the F1 score for each of these groups. Not only entity length, but also entity frequency, consistency, and so on. And I made two observations. And in both observations, the multilingual BERT, German BERT and German Electra were more robust. So what were these observations? The first one is that with the increasing of the entity length, the performance degrades. And also the type ambiguity, which I mentioned in the beginning, which is some words can have multiple labels depending on the context that they are being used in. So the models having contextualized embeddings seem to be dealing with such cases better than the ones with static embeddings. But of course, it's not enough to have models that perform good now, because languages evolve, new entities come up all the time based on major world events, for example, COVID, which brought up new entities, and also the war. So how do we make sure that our deep learning NER models will pick up on new entities? Well, the answer or what I did was transfer learning, which is a method where we reuse a pre-trained model as the starting point for training a new one for a different task or on a different domain. So in NER, transfer learning is simpler because we are doing nothing else but fine-tuning an existing model on a new domain. And usually these new domains are low data domains. So to prove my point here, what I did is I took two of the models that I trained during the first task, and I evaluated them on a test set of a new data set in German, which is the Europarl data set. This is a very small data set consisting of parliament sessions and discussions in German. And as you can see, the performance before fine-tuning was not very satisfying. You can see for the model pre-trained on CoNLL-2003, it achieved an F1 score of 71.69, and for GermEval, a score of 62.89. Here I must say also that the consistency between annotations on different data sets impacts the performance a lot, because for some entities which are actually classified as entities in one data set, maybe the other data set does not consider such entities as entities. So what I did is I resumed training, or I fine-tuned these models on a new small training data set from Europarl. And as you can see, after the training, the performance on the test set jumped from 71 or from 62 to 91 and 93 respectively, which is a huge jump. However, here we must be careful about something. When fine-tuning these models, we should take into consideration that we do not want the models to forget what they have learned so far. So we do that using a smaller learning rate and training on fewer epochs. So this is how I improved the performance on a low data scenario such as Europarl. And now let's go to the next task for building multilingual NER. In real life scenarios, we are faced with texts in different languages. So the standard approach is implementing a language detection mechanism, and then based on the output, you select the appropriate model for that language. However, this requires some efforts into implementing this mechanism, efforts into training one model per language, efforts into finding data sets for each of these languages. So I took another approach. I wanted to exploit the cross-lingual capabilities of multilingual BERT, which is a language model trained on 104 languages. So I used this information to train a single model for NER on a multi-language corpus. So I was able to find some data for English, German, and Dutch from the CoNL-2002 and 2003 shared task, and these were the results. As you can see, for the German language, the score is a little bit lower than for English and Dutch. That's because historically, the performance of NER on German has not been as good as in the other languages because of different properties that the German language has. For example, all the nouns in German are capitalized. Meanwhile, in other languages, only the entities are the ones that usually start with an uppercase letter. So the NER system is often confused in German because of this. And however, we were able to achieve good results for English and Dutch. For English, the F1 score went above 90, and for Dutch, it was close to 90. It was 89.2. These are some encouraging results for the single model approach for multilingual NER. And I still haven't experimented with it, but I think it might be a good choice for training NER models on languages that might not be so well resourced. So what do I mean with well resourced is that for a specific language, there might not be sufficient training data, training label data, because labeling for NER is also something which is expensive in time and also other resources. Sometimes languages have share similarities with each other. So it might happen that this model that I trained might have different, decent results even in some other languages that I haven't trained it in. So yeah, this can be a good idea for lesser known languages or for languages that do not have as much data as the languages that I'm talking about. So yeah, these were my three. So these were the three aspects that I worked on. Now we go to the conclusions. These are just what I think that you can take away from my presentation, maybe have them in mind while you're developing something which is NER related. So the named entity recognition is a precursor step in many NLP downstream applications. So it is important to have high quality NER systems. We saw how deep learning based approaches show better results or have outperformed the classical conditional random fields and have obtained state-of-the-art results in many languages. The choice of word embeddings was very important in the performance of NER. Contextualized embeddings dealt better with lengthy entities and the type ambiguity problem. So as a result, NER models using them are more accurate in extracting and labeling named entities from text. And we showed this also through the F1 scores that I showed. Fine-tuning was a technique for ensuring that the performance of the NER models that we have trained does not significantly degrade for different unseen domains. Retraining such models on a small amount of data is enough for them to pick up on new entities. And we also observed how the cross-lingual capabilities of multilingual BERT embeddings can be used or can be useful for training multilingual NER models. So this eliminates the need for special language detection mechanisms and several models for each language. I think this is where my presentation comes to an end. I hope I was easy to follow, and I did not include a lot of information that was hard to catch up with. However, we have a session of questions, so I'm very happy to answer your questions. Thank you.
Thank you, Andel. This was very inspiring and deep dive.
Thank you.
Into, yes, NER. I start. I see already questions coming in from the participants. So please send us your questions. But I start. What are your next steps? What is your research and development plans in AI? You Andel, what are you going to do next?
Yeah, so I started having interest in AI during my job as a student at Fraunhofer. I was, like you said, I was introduced to many AI applications, and we are developing our own. At the moment, I have left it a little bit aside because I'm concentrating more on software development, but I think there will come a time when we will be looking or researching for better performing models. And since we are trying in the company to switch to AI models or to incorporate AI in our solutions, I think that will be something that will gain some importance in the months to follow. I'm more concentrated in the text-based solutions, deep learning solutions, because there I have some more understanding what's going on because of my thesis. So yes, that would be the answer.
Okay, thank you. So I'm always switching to Emre Sevinch. I hope the name is right. Which tools would you suggest for text annotation? data labeling, for example. For example, Prodigy from Spacey developers or something else?
Spacey is also another solution. I remember that at some point I was comparing the performance of Spacey, for example, with the performance of the models that I have myself trained using the Flare framework, and it wasn't as good as my models. So probably Flare framework is a really good starting point, I would say. But of course, you can use Spacey, you can use, there is another one, but I think that one is only for German. It's called Hanta. It allows you to annotate text like part of speech, named entity recognition, lemmatization, and so on. So yeah, I think these would be the best tools that, in my experience, that I have experienced so far.
Okay, thank you. Next question. How about the problem of bootstrapping when it comes to developing, training NER for totally new entities? I mean, how much annotation would you need?
Yeah, that is a good question. There is not a lower limit. However, I would suggest that like if you want a customized labeling model, so if you do not want a model for person, location, organization, but you want your own entities, it also depends on the number of the labels. For example, if you have a small number of labels, if you have 3 or 4 types of entities that you want to detect, then the number of examples should not be, or not should not, but it is allowed to not provide as many data as you would provide with in case you had a larger number of entities, for example, 10 or whatever. From my experience, maybe 3 to 4,000 of entities per type. That looks like a lot, but yeah, I mean, these are deep neural networks, so some amount of data would, the more you have, the better it is, of course, but yeah, I would say 3 to 4,000 for each type. And we should also be careful that these examples are uniquely, not uniquely, are equally distributed among the entity types. So you cannot have, for example, 2,000 examples for persons, and then you can have 10,000 examples for locations. That is not good, and you will experience problems if this distribution is not equal among the entity types. I feel like I talked a lot about this, but yeah, even I do not have a clear answer to this. It just comes with experience. Labeling is, of course, a difficult task, but yeah, I would say 3 to 4,000 per each type.
Okay, great. I think this is very good detailed answer. And now, do you have language detection tools, libraries, recommendations for?
Language detection tools.
Not detection tools, library recommendation. I mean, language detect. Ah, yeah, doch. Sorry, language detection tools, yeah, and libraries.
Yeah, unfortunately, I haven't worked much on the area of multilingual. Yeah, so I just know that Google, the Google Translator API provides a language detection mechanism, but more solutions at the moment I cannot come up with. Yeah, I haven't worked a lot with such tools.
Okay, next question. Sorry, a lot of questions. Thank you for sending all the questions. How resource intensive is fine tuning with respect to CPU and RAM usage, GPU usage, etc., in terms of requirements?
So for the training of these networks, I use the GPU. The name of the GPU at the moment I cannot remember, but I know that it took me, for training from scratch, it took me 5 to 6 hours when I was using contextualized embeddings, and when I was using static ones, it was taking me 3 or even less. And then during fine tuning, it took me less, of course, because I was using a smaller number of epochs. So I would say around 2 hours and a smaller learning rate. So it takes longer when you are training from scratch. When you are training, when you are fine tuning, it takes considerably less. I also remember that there was a time when I was training only on CPU. For that, of course, it took more hours. At the moment, I do not remember because I've trained these models 1 year ago or more. But yeah, to give an answer, I would say 15 hours maybe for the contextualized embeddings. It also depends on the dimensionality of embeddings. The more dimensions you have, the longer it will take. It's not something that it depends on a lot of factors.
Okay, thank you. And the final classic from Emre. Will your presentation files be available? Will you, I mean, practically, will you send it to, can the people who want to have it, can they get your presentation?
I'm happy to share them. I was also based on my thesis for this presentation. So in case you would like to have that as well, I'm happy to provide it. Just write me an email. I think my email is in the first slide.
Yes, Andel Gugu at eis.fraunhofer.de. We see it.
Yes, it is simple. Whoever has interest can just note it down and can send me an email later.
Yes, because it's also nice. I always say this is a network directly peer-to-peer. Please use emails.
And I think this will also be uploaded on YouTube, so you can have the slides even there. But I'm happy to provide them on demand.
I think this is nice because then you also know who's interested in you.
Yeah,
it's not so
that's true.
Anonymous. And here a question from Martin Wells. How long did it take to train the best model? The best model, maybe.
The best models were the one using the German BERT and German Electra. These models are bigger in size and they take longer to train. I would say 8 to 9 hours. For I think I trained them on 100 epochs. So yeah, that answers the question, 8 to 9.
Cool. And now from Sivam Pasupati Pillai. Sorry when I'm very bad with names. You have mentioned Flare as your go-to choice for NLP library. I've heard of and used Spacy. Is there a clear winner in the NLP library space, in your opinion?
I think it depends on what you want. Do you want speed or do you want your system to be reliable and to be more accurate? Flare, in my opinion, is more accurate. Of course, it depends on the data that you are feeding it to, but it is more accurate, but the models are bigger. Therefore, there will be slower for the inference and slower also to load in the memory. Meanwhile, Spacy is very compact, is small, but the accuracy is not as good as Flare. So you always have to have this fight into your mind. Do you want speed or do you want accuracy? Based on the trade-off, then you can choose. So no, there's not a clear winner even for this.
Good. I just want to give you a compliment, Andel, for giving such great answers already. Emre, who asked a lot, he said, thank you for a lot of excellent detailed answers. So just give you
Thank you very
a
much.
compliment. But they don't stop asking questions because
no.
did you use that's Martin Wells again. Did you use GPU acceleration during training?
I use the GPU, but I don't know what he means with GPU acceleration.
Okay,
if
Martin.
that's some other thing than using a GPU, then no, I haven't used.
So Martin, you have to, if you feel like, send more clear. Now to Karl Bernhoft. Good talk, thanks. I'm curious about NER in practical settings where out of vocabulary words can occur and we won't have the opportunity to fine-tune the model, like question answering we're doing right now. Do you know how online learning for NER compares results?
I didn't understand the question. Can you repeat it?
Yeah, erstmal good talk. I'm curious about NER in practical settings. So he has a practical application where out of vocabulary words can occur and we won't have the opportunity to fine-tune the model. So in like we do right now in this improvised question answering, you have really no time to fine-tune anything. So we both talk, and do you know, and then comes the question, do you know how online learning for NER compares results?
Yeah, I don't have a clear answer for this question because I do not understand it very well, to be honest. But yeah, you can send me an email. We can exchange ideas. I think I need some time for this question to understand it better and also to give a clear answer. I'm sorry.
Yes. So no, you have the email from Andel. Please send the question directly. So Nicole Macher, did you only experiment with an BI-ISTM plus CIF, or did you also directly fine-tune BRT? That's the first question. And then comes the questions. I read the second one. Does a BLSTM plus CIF have any advantage over directly fine-tuning BERT? That's a similar question, no?
So for the first one, I only worked with BLSTM CRF. So I took this architecture, but I trained my models from scratch. And also for the fine tuning, I just resumed the training. I hope this answers the first question. And the second one, can you repeat it once again?
Repeat. Does a BILSTM plus CRF have any advantage over directly fine-tuning BERT?
Over directly fine-tuning what?
BERT, B-E-R-T, BERT.
Okay. That one I haven't investigated. Yeah, I haven't investigated that. Maybe it would be a good, yeah, a good research topic to compare how it does compare to the fine-tuning BERT. But no, I haven't tried that, so I cannot answer.
Okay, so next one, Natalie, what about the French language?
The French language, there is also a corpus for French, so it is not difficult to find annotated data for French. However, in my choice, I didn't include French. But as I said, Flair offers pre-trained deep learning NER models. And I think they also include a model for French. So if you're interested, you can just go to their website. It is very easy to find. Just type Flair NLP, and I think it will be the first result. And there is a table with all the available models that they have. They should have a model for French.
Yes, good. So I think we're coming slowly to the end, but here, Karl, he tried to clarify his question. He wants to once more give it a try. I meant how online learning of NER compares to offline training learning. No? So the difference between online learning and offline learning. And now we try to get the whole question once more. So once more, I'm curious about NER in practical settings where out of vocabulary words can occur and we won't have the opportunity to fine-tune the model. This was the. Do you know how online learning for NER compares results to offline learning? Is that clearer? No.
Yeah, not really. I'm sorry.
Yeah. So try an email. We are coming back to them.
Okay. Yeah.
Yeah. Try an email and send direct to Andel. Please, Karl, try, and then because now it's too difficult as you cannot speak yourself. So, and now I want to thank everybody here. I have my last question for you, Andel. It's just like an easy one. Will your technology be available on this AI on demand platform or somewhere?
I think that the technology is already there in the AI on demand platform. You can find it under the name Entity Recognizer. I think it has been there since last year. Yeah, there you can find a Docker container. You can download and experiment with it, try it out. We are including the multilingual NER model, so the one with multilingual BERT embeddings for German, English, and Dutch. So yeah, it is there, and you can try it out.
Yes. Practically, where do we find it? In like, I think we find it over this, for example, AI for Media platform, and if nobody just AI for Media.
Yeah, you find it in the AI4Europe.eu/research/AI catalog.
Cool. Okay. Thank you. So now I want to thank everybody, especially you, Andel. Thank you very much for being here. And you really did a great presentation. And there were a lot of questions. I must say you did really great job. And also for you, everybody in participants here in the cafe, as always, I'm very happy you were here. And if you feel like getting in contact with Andel, with maybe having more questions or getting the presentation, please contact directly Andel, and I will make sure that I send the recording to Andel as well directly of this cafe. And if you feel like this is okay, Andel, then I will upload it on YouTube, and then you also find it in this typical AI Cafe YouTube archive and on the website. So thank you. You want to say something last? And
yeah, I just wanted to say thank you to everyone for attending, and thank you for asking your questions. I'm sorry if I could not answer some of them, but yeah, we can always communicate directly and exchange ideas. I'm very happy for this opportunity, and I hope that you could learn something out of this. So yeah, thank you.
Okay, have a nice afternoon. Bye-bye. No?
Thank you. You too. Bye-bye.